we will be solving the practice set 1.2. Actually, these are very simple questions. They are very simple. Now we will quickly try to solve it. Okay. So it is based on the concept of equal set and types of different sets. Okay. So the first question is, decide which of the following sets are equal sets and which are not. So they have given 3 sets. Now I will try to write it in listing method. Okay, using listing method, how it will look like. A. Okay, in A contains all such x such that 3x minus 1 is equal to 2. So first I will write the condition and I will solve for the value of x. So 3x is 2 plus 1. This minus 1 goes that side and becomes plus 1. And this implies 3x is 3. And this will imply x is equal to 3 by 3, that is 1. Okay, so x value for x is 1. So my A will look like 1. Okay, now let's see what is set B. Set B says it contains x such that x is a natural number but x is neither prime nor composite. Which is that number which is neither prime nor composite? Only one such number exists and it is 1. Okay. Now let's see the next set. C contains all such x such that x is natural number. So x is natural number and x is less than 2. Natural number means the number will start with 1 and less than 2 means only 1 is there. Next number is 2 and it is not less than 2, it is equal to 2. So C also has only one element. All these 3 sets are singleton sets. That means it has only single element, and if you observe, all the element is same. That means our conclusion is A is equal to B and it is equal to C. A is equal to B, B is equal to C, A is equal to C. All are true. They all are. A and B are equal sets, B and C are equal sets, and A and C are also equal sets. Okay. Second question. Actually, the second question is also almost same. They have given A and B and we have to find if they are equal. Question number 2. In the question number 2, A is even prime numbers. So even prime number, which is the only even prime number that exists? It is 2. We have already discussed it in the previous reviews. So this is a set of even prime numbers. And next is x given 7x minus 1 is same as 13. Now we will solve for the value of x. 7x minus 1 is same as 13. That means 7x is equal to 13 plus 1. That means 7x is equal to 14. So x is 14 divided by 7. That is same as 2. So again we have only one element in B, that is 2. So for this question also we conclude that A is equal to B, or which means A and B are equal sets. Okay. Now we will discuss question number 3. Okay. Question number 3 says, decide which of the following sets are empty set. Now the first sub question is, set A is set of all such A's such that A is a natural number smaller than 0. Now the natural number starts with 1. Natural numbers starts with 1, and then 2, and then 3, and then 4. The least natural number is 1, and that too is greater than 0. So we cannot find any natural number which is less than 0. Okay. So A is empty set or A is null set, because we need to write the reason also. Because the least natural number that exists is 1, and 1 is greater than okay. That reason is enough for us to tell that A is a null set. Now let's see which is next question. That is B. We have given B is equal to set of all such x such that x square is 0. Okay, 0 is square of which number? 0 is square of 0. So set contains one element, therefore it is not empty set. Now we will take the next sub question, that is the third sub question. The question says C is set of x such that 5x minus 2 is 0 and x is a natural number. So let's solve for the value of x. It says 5x minus 2 is equal to 0. That means x is same as 5, x is same as 2 will go that side, will become plus 2, and then x is same as 2 by 5. So one condition was that x should satisfy with this equation, and the other condition was x should be a natural number. Now here from this equation we got x to be 2 by 5. Now 2 by 5 is not a natural number. So again we cannot find any x such that it is a natural number and it is satisfying this equation. So but 2 by 5 does not belong to n. Therefore C is equal to null set, or how can we write it using symbols? Is equal to null set. Okay, so we are done with question 3. Okay, the next question says we have to decide which of the following sets are finite or infinite and give reason for it. Okay, so the first sub question is set A such that x, set of all x such that x is less than 10 and x is a natural number. So we will try writing the set. X is less than 10 and x is a natural number, so x starts with 1 and then 2, 3, 4, 5, 6, 7, 8 and 9, and I stop here because I want this condition to be satisfied, that x should be less than 10. Until 9 the condition is satisfied. Now so here A has limited number of elements, so A is finite. Therefore A is finite. I think we need to write it more precisely. A contains number of elements that is 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. Hence, A is a finite set. Next, B is same as set of y such that y is less than -1 and y is an integer. Okay, here we have the number line. And goes on. So we need all such integers such that it is less than -1. So that means B contains -2, -3, -4, -5 and unlimited number of elements. So this set is infinite. B has unlimited number of elements. Therefore, B is infinite. Okay, so let's get into the third sub question. Okay, the third sub question says C is set of students of class 9th from your school. Now we have to decide this set is finite or infinite. Okay, so in your class, you know the strength of your class, right? Your teacher may be taking attendance daily and she definitely knows how many students are there in your class. That means there are limited number of students. There is a count for it. Yeah, your strength of your class may be 60, 62, 65 and in some schools it is very less, 20, 25. But whatever it is, for a particular class there are only limited number of students and the strength of the class many of you will know, and at least the class teacher of the class will know the strength of the class, right? So there are only limited number of students. Therefore, C is a finite set. Okay, the fifth sub question is set of apparatus in a laboratory. Here also the set is finite. Why? Because apparatus means all those instruments that we use for experiments in a laboratory. Okay, you might have seen laboratory in your schools, for the science laboratories, for particularly for practicals. But there are larger laboratories in hospitals or in research centers. But wherever it is, any lab will have a perfect record of all the apparatus they have in the particular lab. Okay, so it is a countable set and we definitely know how many apparatus, what number of apparatus is available in the laboratory, and we will find such records already preserved. So if we notice, only limited number of apparatus will be there in a laboratory. Limited. So this set is again finite. Now set of whole numbers. As I already discussed before only, that all this fundamental set of numbers, that is set of natural numbers, whole numbers, rational numbers, set of real numbers, all such number set are infinite sets. Okay, so this set is infinite because it has unlimited number of elements in it. Whole numbers means starting with 0, 1, 2, 3 and it continues unlimitedly. Okay, so again this set is infinite. Similarly, set of rational numbers are also infinite because set of rational numbers will look like m upon n given m belongs to I, n belongs to I and n Okay, so this m upon n form, rational number is of m by n form, and m is in an integer, n is a non-zero integer. So the set of integers itself is infinite, and using that we are forming these numbers or rational numbers. So again this set will be infinite. There will be unlimited number of elements in it. So it is infinite set. Okay, so we are done with the practice set 1.2. Please write in the comment section if you have any sort of doubts, and I hope that the type of set and equal set concept is clear in your mind after solving these problems. Thank you. Stay tuned for the next topic.